The topic we'll be studying today is integration. So, what basically is integration? Integration is something that you use to find out the area of a curve. Say you have a curve that looks something like this, and you need to find out from this point to this point what is the area that this curve covers. So you use it using integration, and the symbol of integration is this. So it comes from the symbol summa. You might have seen this before. This being stretched out looks something like this. So why are we using this? Is like, why are you using a stretched out version of summa is because you're finding out the area of this curve, right? So we can divide the area into smaller rectangular areas, really small rectangle. Like this thing would be really small, so we can consider it as a rectangle. So we add all of these areas, so addition of specific areas, that's why we use a symbol that is similar to summa. And to start with integration, you need to know some standard integrals. So for today, you just need to remember two integrals, and that will help you solve a question. So the first one is, if you integrate x to the power n with respect to x, this is our integral symbol. This, after this small dot, what is written is d, and whatever is here is with respect to what we are integrating. So if I say dot dy, we are integrating with respect to y. So integral of this is x to the power n plus 1 upon n plus 1, and n cannot be minus 1. We can get into this later. And the second integral that I want you to remember is 1 upon x with respect to x, which will be log of mod x plus c. So this plus c is, we can again get into it why we are writing plus c, but we can get into that stuff later. So right now I just want you to remember these two integrals, that when you integrate x to the power n, you will get x to the power n plus 1 upon n plus 1, and if you integrate 1 upon x, you get log x. What I mean by n here is, so an example of this, if I say I want to integrate x square, so what I will get out of this is x to the power 2 plus 1 upon 2 plus 1, which is x to the power 3 upon 3. So this is what I mean by n here. So let's start with the question. Now if I write that the question is 1 upon x minus x cube. Now it might seem like this is something that is not possible right now, but let's break it off into something that we can do. Like, what if we take out the x from here? This still looks like a question that we don't have like previous knowledge of. Like, we need some more formulas, right? But that's not the case. So here if I say, what if I can break it off into two parts such that this doesn't look like so complicated. So if I subtract x square and add x square, this looks like something that was in the denominator. So maybe I can try to see what the whole thing would look like if I break this off after this using this plus. What I mean by that is, if I write it down like this. So let's see how this look like. So here I will cancel this off, and here I can do this. So here you can clearly see that this is just the formula that we noticed, like the second formula that I told you to remember was what is the integral of 1 upon x, and this is the same thing. So integral of this was log x. Now what about this half? Now we do know the integral of 1 upon x, right? And like if we change the variables a bit, we know the integral of 1 upon t. So can I change it into something like that? This does kind of look like a differential, but without the 2 to me. So if we consider this to be t, we can clearly see that dt, if this is t, dt would be minus 2x. And if I multiply and divide minus 2, I'll get something similar. So this would look something like this now. And if I put t instead of everything, so here this whole thing would also include like dt upon dx would be this. So dt would be minus 2x upon dx. So we can replace dt here with this whole thing because of this, and below this is t that we just said, and here is 2. So we get dt by minus 2t. So integral of, again, constants can be taken out. In integration, I forgot to mention this, but in integration the constants can be taken out at any point. So this simply becomes the problem that we just saw. So the answer of this would be log of mod t with 1 upon minus 2. And like if you are giving your answer in a paper, you will write log x plus and change this t back, 1 upon 2 log of 1 minus x square. So what this problem was, you're familiar with miscellaneous exercise, right? So that is the toughest kind of thing that children find throughout their mathematics career, like throughout their 11th, 12th. So this is the first problem of your miscellaneous exercise of integration.